All right, we're thinking about arc length. Now, if you remember from geometry, we said the length of an arc was equal to the central angle's measure out of 360, basically the fraction of the circle that we're talking about, times the circumference. Now, we here in pre-calc are thinking a little bit different. Instead of the length of the arc being expressed something like this, we use that lowercase s to talk about the length of our arc. And when we're talking about that central angle measure, we use theta, so I'm going to replace m with theta. And when we're talking, recently we're talking about using radians, and so 360 degrees in radians would be 2 pi. So if we just change things to what we now are talking about, this in a kind of a more mature way, thinking about radians and all of that, and we plug it in, well, notice what happens. That 2 cancels out, the pi cancels out, and we're left with s. The length of that arc is equal to our measure of that central angle in radians times the radius. And if you think about what we've defined our central angle in radians to be, it is the ratio of the intercepted arc to the radius. That is our definition for radians, essentially. And notice all this is a rearranged version. If I were to solve for theta here and divide both sides by r, I get the same thing. So the length of our arc, if we're dealing with radians, the length of our arc is simply going to be that central angle measure in radians times the radius. That simple. Here we want to find the length of the intercepted arc for each angle given the central angle measure and the radius. All right, we want to round to the nearest tenth if we need to, but let's see here. We have the measure of our central angle in radians. We have the radius. Remember, the length of our intercepted arc is going to be the central angle measure in radians times the radius. So pi over 4 times 5. Well, if we multiply that out, we would get 5 pi over 4 centimeters. I would rather you keep it in exact form, but if you round it to the nearest tenth, you could plug it in your calculator, you could get 1 decimal place there. Over here, 60 degrees. Now, 60 degrees, here we're working with degrees, so remember our original formula, the measure of the central angle over 360, that's the fraction of our circumference times 2 pi r. Well, this is 1/6. 60 over 360 would give us 1/6 times 2 pi times 2. Because our radius is 2, so we have 1/6, that would be 4 over 6 pi. And 4 over 6 pi reduces, give me 2 pi over 3, and I am working in inches. Once again, if you wanted to round to the nearest tenth, you could plug it in the calculator and round to the nearest tenth, but this exact form is even better for